Today's lesson will introduce alkyl halides and the reactions that can be used to create them. Not all organic compounds are made up of only carbon and hydrogen. Some hydrocarbon derivatives contain other elements. When organic compounds contain other elements, they are said to contain functional groups. Functional groups are characteristic arrangements of atoms within a molecule that can be used to predict chemical and physical properties of the organic compounds. Here are the different functional groups that you will be expected to remember. You have already learned about alkanes, alkenes, alkynes, and phenyl groups. Over the next week, we will be looking at more functional groups. Organic halides are organic molecules where the hydrogen has been replaced by a halogen atom. They are also sometimes called alkyl halides or halogenated hydrocarbons. In the case of organic halides, the functional group is the halogen atom that is bonded to the parent chain. Many well-known organic halides are toxic. DDT and PCBs are extremely dangerous to animals and humans. Depending on where the halogen group is located on the parent chain, organic halides may be polar or nonpolar. If the halogen is toward the center, leaving hydrocarbon ends on the parent chain, the molecule would be nonpolar. If the halide is on the end of the parent chain, the molecule would be polar. Organic halides have higher boiling points than their corresponding alkenes. They have lower solubility in water, but they are more soluble than similar hydrocarbons. The naming for organic halides depends on the type of halogen that is in the functional group. The rules are the same as for regular branches on a parent chain. For this example, we start by identifying the parent chain. It has 6 carbons, so it is hexane. The chain has 2 bromine groups and 1 chlorine group, so the branches are listed in alphabetical order, similarly to how we have been naming alkyl chains. This organic halide has cyclohexane as its parent chain. Begin numbering at the bromine and continue with the lowest possible numbers. This molecule has 1 methyl group and 2 bromine groups. Branches should be listed alphabetically. Addition is a reaction that unsaturated hydrocarbons such as alkenes or alkynes undergo to produce alkyl halides. The alkenes react with halogens to produce organic halides in the presence of a catalyst. The reactions are favorable because carbon is more stable with a solid octet and tetrahedral structure than that it has when it has 4 separate bonds. Hydrogenation is also considered an addition reaction. In this case, the alkene or alkyne reacts with hydrogen to become saturated. The ability of your reaction to take place does rely on an adequate number of moles of reactants. If 1 mole of bromine is available, there would be an addition of 2 bromine atoms, 1 on each side of the double bond. If more bromine was available, then the addition reaction would yield a different product with more bromine atoms attached and a single bond. Substitution reactions can also be used to create organic halides. These reactions only occur on saturated hydrocarbons such as alkanes and aromatic rings. The hydrogen atoms in the molecule are replaced with another atom in the presence of light. The general reaction here shows that alkanes or aromatics react with the halogens in the presence of light to form organic halides. In this reaction, one of the hydrogens is replaced by a bromine atom. The bromine can either be attached to an end atom or a middle atom. This means that there are actually 2 different possible products. Both products are produced, but in different amounts. Although benzene is very stable, it will undergo a substitution reaction. It can continue to undergo these reactions until all of the hydrogens are replaced with halogens, but the process is very slow and requires light and a catalyst because benzene is so stable. Please complete the November 16th quiz.